I'm going to go over the problem in Chapter 3, number 8, because I think it shows a lot of elements of how to work with vectors. And I'm going to add some more things to it than what's being requested in the book. Okay, so I'm going to use the book numbers. And what happens is there's a person who does the following. He walks 3.1 meters to the north, or sorry, 3.1 kilometers to the north. So draw a picture of it. And then he walks 2.4 kilometers to the west. And then he walks 5.2 kilometers south. So always start with a picture and try to make it, roughly speaking, according to scale. And then the question asks, where does the person wind up? And you have to write a vector for that. So what it's asking for is the resultant. So I'll make it dashed like this, and I'll call it R. And it's also helpful to label your vectors. So I'll just label them A, B, C, and D, and A, B, C, and R. And let's just see what we can do with it. So you want to find something about R, and the easiest way to set this up on your paper is to write clear expressions for the vectors in unit vector notation. So what that means is that A is represented by 3.1 kilometers j hat, B is minus 2.4 kilometers I hat, and C is minus 5.2 kilometers j hat. And the resultant is equal to the vector sum A plus B plus C. You should also notice that sometimes these vectors might be represented like this. So A would be here, B would be here, and then C would be here. And you should be able to slide the vectors so that you get a pattern that looks like the diagram on the left. So that would be the geometric addition of vectors. All right, so let's just try to figure out what R is going to equal in terms of the magnitude and the direction. So what you want to do is just plug in all the unit vectors. I'm writing everything out, but down the line you won't have to do that. So that's your A, that's your B, and that's your C. And then you simplify by grouping the I hats and the J hats. And you will get this. And then what you want to do is check whether your answer is sensible. So if you drew your R vector like this, and you resolved it, I'll put the resolved vectors in red. You have to draw two vectors that lie along the axis. So it looks like this. And then this one would be your RY vector, and this one would be your RX vector. And what you're seeing is that RX over here is a negative, so that means it points to the left, and RY is negative, and that means it points to the left. So everything makes sense. I'll take these lines out now. Okay, then the question wants you to figure out the magnitude of R, so you can look at, you can use Pythagorean Theorem. You see that this is a right angle. And so what you would say is that R squared equals RX squared plus RY squared, where RX and RY are magnitudes as well. And then you would find that R equals the square root of 2.4 kilometers squared plus 2.1 kilometers squared. You don't have to put in those minus signs because when you square it, they go away anyway. So then you plug it into your calculator and you will get something like 3.19 kilometers. Don't forget your units. Now the next part is to figure out your angle. And what you have to do is draw a sensible angle in your picture. And I happen to choose this one, theta being that angle in the upper corner. And then you want to look at your triangle, and then you're going to say tan theta equals. Now it's always helpful to deal with nice right triangles. And then what you want to do is look at the opposite length and the opposite length is 2.4. Notice how I put a plus value on it because I'm looking at a length. And then in the denominator, the opposite adjacent is 2.1. And again, I made it positive because I'm dealing with a simple little right triangle. I don't have to worry about the theta relative to the x-axis and things like that you do in math class. And then what I want to do is stick it into the calculator, and you will get theta equals to 48.8 degrees. Now you have to express this properly. So in this particular case, it's 48.8 degrees west of south. But it is also possible that Wiley might want you to express the angle relative to the x-axis, in which case what Wiley is saying to do is, if your r is like this, Wiley wants you to find that angle, which I will call theta prime, and this angle here is theta. So if you look at this picture, theta is 48.8, but this angle, let me draw it in red, this angle phi is going to be 90 minus 48.8, which is equal to 41.2 degrees. And therefore theta prime, which is the angle relative to the x-axis, will be 180 degrees plus 41.2 degrees. So that'll be 221 degrees. Okay, so it all depends on what angle the problem wants. It doesn't really matter so long as you're not ambiguous about the answer. So that's it. I'm stopping the recording.